supposedly this was working earlier, and I did it once, and I've done it twice. So let me see if I got this. All right, so I was just going to walk you guys through the NNT calculation, how you put it together, how you make a, how you break this down. So you're going to take your adverse events that happen from a study. You're going to have a yes and a no group. And then you're going to have a group that got treated and a group that got placebo. And so this is going to be A, B, C, D. So we're going to set this up. So in this study, they gave people a poison ivy treatment or placebo, and then some people were cured of their poison ivy and some weren't. So we want to see if the treatment worked and how well it worked, essentially by figuring out how many people we have to treat according to this study. So 4 people were given the treatment or the intervention, and they showed poison ivy. 12 did not. There was also 8 that were given the placebo and 8 that were not. Or 8 that did not show any poison ivy, but did not get the treatment. So the equation is 1 over the ARR, which is C over C plus D, which are these 2 groups. So this is your placebo group. And then you have your treated group, which is A over A plus B. So this is your NNT, number needed to treat. So we just need to plug and check. So you have 8, and then 8. Minus, which is 4 over 4 plus 12. And this is all over 1. So this small section is equal to 0.5. And this small section is equal to 0.25. And find the difference. That's 0.25, just in the bottom half. This is all just the bottom half. So in the end, you would have 1 over 0.25, which would equal to 4. So if that's really, really fast, I'm going to go through the second one. So let me erase all this out and hope that this all right. So the way that we are going to be given the question is going to be like this. This is what we're going to see on the exam, is something like this. Not exactly this, but something like this. So you will see that you'll get a total population. So we have 3,000 women that were treated with the vaccine and 2,000 women that were given the placebo. So that is your total population. That's not the difference between the ones who have had the adverse event and those who did not. So 4 of the women that were treated got the adverse event. So 4. Those were treated. However, 8 with the placebo also got an adverse event, which that adverse event is cancer. So which ones did not have an adverse event? So the ones that were treated were 3,000, and you have to take out the ones that had the adverse event. So that is 2,996. And then this is 2,000 minus 8. So that is 1992. So that's these two numbers. So then plug it into your equation. So 8 over 1992 plus 8. And then your A is 4 divided by 296 plus 4. So then you have 8. Clear this off. All right. 8 divided by 2,000, because 1992 plus 8 equals 2,000. So your first number on the bottom right here will be 0.004. And then your second number over here will be 0.0013. 0013. So what is your difference? Hide this. So 0.004 minus 0.0013, okay, equals 0027. And then this is your ARR, not your NNT. Your NNT will always be a big, nice round number. So 1 over 0.0027 is equal to, I know it's over there, ignore that it's over there. So it will be 370.37. Well, there's a problem with this because you can't have this on the end. You have to round it up or down depending on your adverse event or whether you do sig figs or not. So sometimes people will round this up if it is a positive event like treatments, or if it's a negative event like deaths, they'll round it down. But here, this is rounded up because that's what she did. So you have a nice solid number of 371 people that are needed to treat to prevent one person from getting ovarian cancer. So it is just a plug and chug. I would suggest trying to go through here on this table and looking at it and being able to plug the numbers, because that's a great way to run through it, and figuring out how you round stuff. But that is it for this. So let's see if we can figure out how to end this. So we're going to stop sharing, and then we're going to stop